All right, welcome to our lesson on scientific notation with positive powers of 10. It's the first of two lessons in Unit 2. We're going to talk about scientific notation. Scientific notation is a fancy way to take really large numbers and make them smaller. You're going to see scientific notation in your science class. So this is a lesson that's both usable here and there. And it's used to deal with really huge numbers, like 300 million meters per second, which is the speed of light, and really small numbers like the diameter of a single atom. Now, in this case, this is easy to write. It's 3 times 10 to the 8th. If you think about it, 10 to the 8th is 10 times 10, 8 times. Or you could write it as 1, 2, where did my 1 go? 3, 4, 5, 6, 7, 8. And I can put my commas back in here. So 10 to the 8th is really 100 million. Times 3 is 300 million. Now down here, when you get to negative numbers, this is a positive exponent, which means the number gets bigger. Negative exponents are used to represent numbers that are smaller than 1, like 0.00000000001. That's a small number. But that can be written as 1 times 10 to the negative 10. Which helps us. That's the next lesson. We're only going to worry right now about positive exponents, which is a number greater than 1. So to convert scientific notation, count how far you need to move the decimal. So there's only one digit, and that digit's 1 to 9, in front of the decimal. You cannot have more, in scientific notation, you cannot have more than one digit in front of the decimal. So when we move the decimal to the left, we create a positive power. In this case, I've got a big number. I've got 102,400, and I want to make it a positive power. So what I'm going to do is, I apologize, I'm going to get this, is move that decimal. I'm going to move that decimal 1, 2, 3, 4, 5 places. Now, I did that, and I can drop the leading zeros, and now I've got 1.024 times 10 to the 5th, meaning to convert that back, I'm just going to multiply it by 10 times 5 times. So 10 with 1, 2, 3, 4, 5 zeros. Which you think about it, that's what we had here. We had, this is 100,000 times 1.024 will get us our starting number. So converting from scientific notation, you're doing exactly what we did before. So I've got 3.42. I ended up with 3, and I moved it I moved the decimal. It started right there, right? 1, 2, 3, 4, 5 times. And I got 342,000. We're moving that to the right and adding zeros. That's a positive. We're making it a big number. So let's convert these. Over here, I've got 6,400. So I can do that. I move the decimal place, which starts right here. I move it 1, 2, 3 spots, and I end up with 6.4. Can't drop that point. Times 10. To how many times did I move it? I moved it 3 times. Over here, I've got 570 billion. So how many times I have to move the decimals? I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I end up with 5.7 times 10, and I moved it 11 places. A light year is the distance light travels a year. It's equivalent to 9, that's trillion, 461 billion kilometers. What's the distance scientific notation? Well, I can do that easier. I can put 9.461. I've only got one digit in front of the decimal. It's between 1 and 9. I can't have a 0 up there. Times 10 to something. Well, the decimal started here. I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I moved it 12 times. So I write 9.461 times 10 to the 12th. Much easier to deal with 9.461 than it is to deal with 9,461 billion. So let's look at the other way. To go the other way, now I just write my number. And remember, this is the number of zeros, but it's also spaces. So I'm moving this decimal. I got 1, 2, 3. I brought that 034 down. 4, 5, 6, 7, 8, 9. And then I can go put my commas to make it a little easier to deal with. Wow, big number. 7,034,000,000. It's like our national debt. Actually, our national debt's in the trillions. So down here, I got 2.36 times 10 to the fifth. I get my 2. Remember that 10 to the fifth is moving that decimal place back. So if I had 36, whoops, that's 1, 2, 3, 4, 5, 6. Whoops, I went crazy. I stopped at 5. So 1, 2, 3, 4, 5. So I end up with 236,000. All right, the mass of one roosting colony of monarch butterflies are pretty big when they get in Mexico. They just fill these trees. It's funny, they go all that way for one set of trees. Is estimated at 5 times 10 to the 6 grams. What's the mass in normal? So I got 5, and then it would be 0.0, so I just start moving it. 1, 2, 3, disappeared. 4, 5, 6. And then I can do this. So it's literally 5 million grams. That's a lot of butterflies. So I hope that helped, and I hope you're onto this. Scientific notation is just about practice. Remember, it's all about that 10 times something to the positive power. That's all we're dealing with. Good job.